Hey there, get comfortable, grab a blanket if you need one, and settle in, because tonight we're going on the longest journey imaginable, not through space, but through time. Before we start, drop a comment and let us know where you're listening from and what time it is. We love seeing how far this reaches. Alright, so here's what we're doing. We're going to travel back 4.5 billion years, to a time when our planet was young and absolutely brutal, covered in molten rock, constantly pummeled by asteroids, basically a hellscape. And from there, we'll move forward through the ages, watching as the first life emerges from the chaos, as creatures crawl from the sea onto land, as forests rise and fall, as dinosaurs shake the ground with their footsteps. And eventually, we'll arrive here, at us, at you. Because here's the thing, this isn't just some distant history, it's your story. Every atom in your body was forged in ancient stars. Every cell carries instructions written over billions of years. You are the latest chapter in the longest, most improbable tale ever told. So let's get into it. Picture a world on fire. The Earth in its infancy was unrecognizable, a churning ball of molten rock, its surface glowing red and orange beneath a sky thick with volcanic ash. The temperature was unbearable. No liquid water could exist on the surface. No life could survive. But the young Earth was not alone in its violence. The solar system was still littered with debris from its formation. Asteroids and comets, some over 100 miles wide, still careening through space. They struck the Earth relentlessly, some so massive they could vaporize entire oceans. For the first 500 million years, our planet endured this bombardment. Scientists call this time the Hadean Eon, named for Hades, the Greek god of the underworld. It was a fitting name for such a hellish world. But even in this chaos, something remarkable was happening. Deep inside the Earth, the planet was beginning to organize itself. Heavier elements like iron and nickel sank toward the center, forming a dense core. Lighter materials rose to the surface, beginning to cool into a crust. And volcanoes, countless volcanoes, erupted constantly, releasing gases trapped inside the planet. Carbon dioxide, nitrogen, methane, and most importantly, water vapor. Enormous amounts of water vapor rising into the atmosphere, beginning to collect into clouds. As the Earth slowly cooled, something magical happened. The temperature dropped just enough, below 212 degrees Fahrenheit, for water vapor to condense into liquid. And then it began to rain, not a gentle spring shower. This was rain on a scale we cannot imagine. It rained for millions of years. Water poured from the sky in endless torrents, pooling in the low places, filling the basins carved by ancient impacts. About 4 billion years ago, the oceans were born. Recent evidence from ancient crystals called zircons suggests these oceans may have formed even earlier than we once thought, perhaps as early as 4.4 billion years ago. Either way, by the time the bombardment finally slowed, our planet had transformed from a world of fire into a world of water. An ocean covered almost the entire globe, warm and dark, lit only by lightning and the glow of distant volcanoes. Somewhere in that primordial sea, life was about to begin. How does life begin? This is one of the deepest questions we can ask, and scientists are still working to fully answer it. But we know where to look: the ancient seafloor, near places where hot water spewed from cracks in the Earth's crust. These hydrothermal vents were chemical factories, hot mineral-rich water mixing with the cold ocean, creating gradients of temperature and chemistry that could power simple reactions. In these environments, scientists believe complex molecules began to form, the building blocks of life. By at least 3.5 billion years ago, perhaps even earlier, perhaps 4 billion years, the first life emerged. Simple, single-celled organisms. Microbes so small they would be invisible to the naked eye, yet each one a universe of complexity compared to the rocks around them. These first life forms didn't breathe oxygen. There was essentially none in the atmosphere. Instead, they survived using sulfur and other chemicals from the Earth itself. They didn't need sunlight. They thrived in darkness, near the warmth of the vents. For nearly 1 billion years, life remained like this. Simple, microscopic, huddled around chemical oases on the seafloor. But even then, evolution was at work. Slowly, gradually, these tiny organisms were changing, adapting, diversifying. And somewhere along the way, one group of microbes developed a remarkable new ability. About 2.7 billion years ago, a new kind of microbe evolved, cyanobacteria. These tiny organisms developed something revolutionary, the ability to capture energy from sunlight and use it to split water molecules, releasing oxygen as a byproduct. Photosynthesis, the same process that powers every plant on Earth today. At first, the oxygen they produced didn't accumulate. It was immediately absorbed by iron in the oceans, forming rust that sank to the seafloor. You can still see evidence of this today in formations called banded iron deposits, thick layers of rust laid down over hundreds of millions of years. But eventually, around 2.4 billion years ago, the oceans ran out of iron to absorb all that oxygen. And so it began to escape into the atmosphere. This was the Great Oxygenation Event. Over millions of years, oxygen levels rose from almost nothing to perhaps 2% of the atmosphere. It might not sound like much, but it was catastrophic for the life that existed at the time. You see, oxygen was poison to the early microbes. They had evolved in a world without it, and now it was everywhere, reacting with their cells, destroying them from within. Scientists sometimes call this Earth's first mass extinction, an oxygen holocaust. But some organisms survived, some adapted, and some, our ancestors among them, learned not just to tolerate oxygen, but to use it, to breathe. Okay, now we're entering what scientists sometimes call the boring billion. And honestly, fair name. For the next billion years, roughly from 1.8 billion to 800 million years ago, Earth entered what scientists sometimes call the boring billion. It wasn't completely without change, but compared to what came before and what would come after, it was remarkably stable. During this time, life remained mostly microscopic. Single-celled organisms dominated the oceans. Stromatolites, layered mounds built by microbial communities, grew along the shores. The atmosphere held steady. The climate was mild. But beneath this apparent calm, important changes were accumulating. Around 2 billion years ago, a profound transformation occurred. The first eukaryotic cells emerged. These were cells with a nucleus, a protected compartment holding their genetic material. Your cells are eukaryotic, so are those of every animal, plant, and fungus. Even more remarkable, these early eukaryotes absorbed other microbes and put them to work. Mitochondria, the tiny powerhouses inside your cells that convert food to energy, were once free-living bacteria. They were engulfed by our ancestors and became permanent passengers, essential to everything that followed. And around 1 billion years ago, the first multicellular organisms appeared. Simple at first, just clusters of cells that stuck together. But this was the beginning of something entirely new, complex life. The quiet couldn't last forever. Around 720 million years ago, the Earth froze. Not just at the poles, everywhere. Ice sheets spread from the poles toward the equator, covering the continents, creeping across the oceans. At its most extreme, glaciers may have reached the tropics. Some scientists believe the entire planet was encased in ice, a condition they call snowball Earth. For millions of years, the Earth remained frozen. Life survived only in scattered refuges, perhaps around volcanic hot springs, or in pockets of liquid water beneath the ice, or in cracks where sunlight could still penetrate. But volcanoes continued to erupt, releasing carbon dioxide that couldn't be absorbed by frozen oceans or weathered rocks. Slowly, over millions of years, greenhouse gases accumulated until they triggered a catastrophic warming. The ice melted rapidly, perhaps in just a few thousand years, and the world was transformed. And in the aftermath of this global thaw, life exploded. Around 540 million years ago, something remarkable happened. In a geological instant, perhaps just 15 to 25 million years, an explosion of animal diversity transformed the oceans. This was the Cambrian explosion. Before it, most life was simple. Microbial mats, soft-bodied organisms, simple multicellular forms. After it, nearly every major group of animals we know today had appeared. Trilobites, those famous armored creatures with faceted eyes, scuttled across the seafloor by the millions. Anomalocaris, a predator up to 3 feet long with grasping appendages and a circular mouth, cruised above them. Worms burrowed into sediment, creatures with shells, with spines, with armor, with every conceivable body plan, appeared almost simultaneously. What triggered this explosion? Scientists debate the causes. Rising oxygen levels may have allowed larger, more active animals to evolve. The evolution of eyes may have sparked an evolutionary arms race between predators and prey. The end of Snowball Earth may have opened up new ecological niches. Whatever the cause, the Cambrian fundamentally changed the nature of life on Earth. After billions of years of microbial simplicity, the age of animals had begun. And somewhere among those early Cambrian creatures, barely distinguishable from the worms around them, were the first chordates, animals with a flexible rod running down their backs, your earliest ancestors. By the Ordovician period, about 480 million years ago, those early chordates had evolved into the first fish. They were strange-looking creatures by modern standards, jawless, covered in bony armor, with simple fins that could barely steer them through the water. But they were vertebrates. They had backbones. And that simple innovation, a flexible internal skeleton, would prove to be one of evolution's greatest successes. Over the following 100 million years, fish diversified spectacularly. Jaws evolved, allowing fish to become active predators rather than passive filter feeders. Paired fins appeared, giving fish precise control over their movements. Some developed skeletons of bone, others kept cartilage, like modern sharks and rays. The Devonian period, from 419 to 359 million years ago, is often called the Age of Fishes. The oceans teemed with them. Dunkleosteus, an armored predator over 20 feet long, dominated the seas with jaws that could snap shut with thousands of pounds of force. But while fish ruled the waters, something else was happening on land. For the first 4 billion years of Earth's history, land was barren. Nothing lived there, no plants, no animals, nothing but rock and dust and the occasional pool of water. But around 470 million years ago, that began to change. Simple plants, relatives of modern mosses, crept out of the water and established themselves on the margins of ponds and streams. By 400 million years ago, the first vascular plants had evolved, with internal tubes to transport water and nutrients. They could grow taller, spread further from the water's edge. Animals followed. Arthropods, ancient relatives of spiders and scorpions, were among the first to venture onto land, following the plants they fed upon. By the late Silurian period, simple ecosystems had formed along the shorelines. And then, something extraordinary. Some fish began to crawl. Certain lobe-finned fish had developed sturdy, muscular fins that could support their weight out of water. They had lungs as well as gills, able to breathe air. During the late Devonian, around 375 million years ago, these fish began hauling themselves onto land. Creatures like Tiktaalik, half fish, half tetrapod, marked this transition. They had fins, but with bones arranged like a wrist and fingers. They had gills, but also lungs. They lived in shallow water, but could venture onto shore. By 360 million years ago, the first true tetrapods, four-limbed vertebrates, had evolved. Your distant ancestors had arrived on land. What comes next is rough, but it's important. 252 million years ago, Earth experienced the worst catastrophe in the history of life. Scientists call it the Permian-Triassic extinction, or simply the Great Dying. 96% of all marine species disappeared. 70% of land vertebrates perished. It was the only mass extinction to decimate insects. Life nearly ended entirely. The cause was volcanism on an almost unimaginable scale. In what is now Siberia, massive eruptions created a volcanic province the size of Alaska. For perhaps 1 million years, lava poured across the land while gases poisoned the atmosphere. Carbon dioxide levels soared, triggering runaway global warming. Temperatures rose by perhaps 8 degrees Celsius. The oceans became warm and stagnant, losing their oxygen. Hydrogen sulfide, a toxic gas smelling of rotten eggs, accumulated in the water and leaked into the air. The world became unsurvivable for most life. Recovery took millions of years. The early Triassic period was a desolate time. Empty oceans, silent forests, a world struggling to heal. But eventually, inevitably, life found a way. And from the ashes of the Great Dying, a new group of animals would rise to dominance, the dinosaurs. The Mesozoic era, the age of dinosaurs, lasted for nearly 186 million years. It's divided into 3 periods: the Triassic, when dinosaurs first appeared; the Jurassic when they rose to dominance, and the Cretaceous when they reached their greatest diversity. Dinosaurs first evolved in the Middle Triassic, around 245 million years ago. They were small at first, dog-sized bipedal creatures living in the shadow of other reptiles. But after another extinction event at the end of the Triassic, they diversified rapidly. By the Jurassic period, dinosaurs had become the dominant land animals on Earth. Sauropods, the long-necked giants, grew to staggering sizes. Brachiosaurus stood 40 feet tall. Diplodocus stretched over 80 feet from nose to tail. These gentle giants moved through forests of conifers and ferns, reshaping the landscape with their feeding. Alongside them roamed predators like Allosaurus, fast, fierce hunters working in packs to bring down prey many times their size. Stegosaurus wandered the plains, its spiked tail and armored plates providing defense against attackers. The Cretaceous period saw even greater diversity. Tyrannosaurus rex, perhaps the most famous dinosaur of all, dominated North America, a 40-foot predator with jaws that could crush bone. Triceratops, with its 3 horns and massive frill, grazed in herds across the same landscapes. But dinosaurs weren't the only important creatures of the Mesozoic. Pterosaurs ruled the skies, some with wingspans of over 30 feet. In the oceans, massive marine reptiles like plesiosaurs and mosasaurs hunted fish and squid. And quietly in the undergrowth, a group of small, furry creatures were evolving. The first mammals. They were tiny, none larger than a cat, and they lived in the shadows of the dinosaurs, emerging at night to hunt insects and seeds. They had been around since the late Triassic, but as long as dinosaurs dominated, they couldn't flourish. They would have to wait for their moment. 66 million years ago, an asteroid roughly 6 miles wide struck the Earth. It hit what is now the Yucatan Peninsula of Mexico, creating the Chicxulub crater, a scar over 100 miles wide. The impact released energy equivalent to billions of nuclear bombs. Rock was vaporized. Tsunamis hundreds of feet high swept across the oceans. Wildfires ignited around the globe. But the worst was yet to come. The impact threw so much debris into the atmosphere that it blocked out the sun. For months, perhaps years, darkness enveloped the Earth. Temperatures plummeted. Plants died. The food chain collapsed. The non-avian dinosaurs, all of them, perished. So did the pterosaurs. So did the marine reptiles. Roughly 75% of all species on Earth went extinct in what scientists call the Cretaceous-Paleogene extinction event. The age of dinosaurs, after 170 million years, was over. But not all dinosaurs died. One lineage survived. The birds. Today's birds are living dinosaurs, the descendants of small feathered theropods who weathered the apocalypse. When you hear a sparrow sing or watch a hawk soar, you're seeing the dinosaur legacy. And in the aftermath of extinction, those small furry creatures finally had their chance. With the dinosaurs gone, the world lay empty and waiting, and the mammals responded. Within just a few million years, a blink of an eye in geological time, mammals diversified explosively. They grew larger. They spread into every ecological niche the dinosaurs had left vacant. They took to the seas, becoming whales and dolphins. They took to the air, becoming bats. They became predators, herbivores, omnivores. The Cenozoic era, our current era, is sometimes called the Age of Mammals. For the past 66 million years, mammals have dominated the land just as dinosaurs once did. Enormous creatures roamed the earth during this time. Woolly mammoths, with their curved tusks and thick fur, survived until just 4,000 years ago. Giant ground sloths, the size of elephants, lived in the Americas. Saber-toothed cats hunted across multiple continents. But the story we're most interested in involves a particular group of mammals that spent most of their time in trees. About 55 million years ago, the first primates appeared. They were small, squirrel-like creatures that lived in tropical forests, eating insects and fruit, but they had 2 crucial adaptations: forward-facing eyes that gave them depth perception, and grasping hands that let them navigate through the trees. Over tens of millions of years, primates diversified. Some remained small, others grew larger. Some developed longer arms for swinging through branches. Others became better adapted for walking. Around 25 million years ago, the apes split from the other primates. These early apes had no tails, and their shoulders allowed for a wider range of arm movement. By 15 million years ago, A diverse array of apes lived across Africa, Europe, and Asia. And then, between 8 and 6 million years ago, our lineage diverged from the one that would become chimpanzees and bonobos, our closest living relatives. We share over 98% of our DNA with chimps. Our common ancestor lived in the forests of Africa, probably looked somewhat like a chimpanzee, and had no idea that one branch of its descendants would someday walk on the moon. The first hominins, the group that includes humans and our extinct relatives, appeared around 7 million years ago. We don't know exactly what drove our ancestors to stand upright, but walk upright they did. This is one of the earliest features that distinguishes our lineage. Bipedalism freed our hands. It changed how we moved across the landscape. It may have helped us carry food and tools. Whatever the reason, it set us on a path that no other ape had taken. For millions of years, various hominin species lived in Africa. Australopithecus, the southern apes, were small-brained but walked upright. The famous fossil Lucy, discovered in Ethiopia, was an Australopithecus afarensis, who lived about 3.2 million years ago. She stood only about 3.5 feet tall, but she walked on 2 legs. Around 3.3 million years ago, someone made the oldest known stone tools, simple flakes chipped from rocks, but revolutionary nonetheless. Before this, no animal had ever deliberately shaped a stone to create an edge. Then about 2.8 million years ago, the first members of our genus appeared. Homo habilis, handy man, had a larger brain than the Australopithecines and made more sophisticated tools. The human story had truly begun. About 1.8 million years ago, Homo erectus appeared, a taller, larger-brained hominin who would become one of the most successful species in human evolution. Homo erectus mastered fire, developed more advanced tools, and became the first hominin to leave Africa. They spread across Asia and into Europe, adapting to new climates and environments. For over 1 million years, Homo erectus populations lived across the Old World, gradually evolving in different directions depending on where they lived. In Europe, a cold-adapted species evolved, the Neanderthals. With their stocky bodies, large brains, and sophisticated tools, Neanderthals thrived for hundreds of thousands of years. They buried their dead, cared for their sick, and created the first known cave art. In the remote mountains of Asia, another group diverged, the Denisovans. We know little about them, just a few bones and teeth, but their DNA lives on in modern humans. And in Africa, during a time of dramatic climate change around 300,000 years ago, our own species emerged, Homo sapiens. Alright, here we are, the home stretch. This is where it gets personal. The oldest known fossils of Homo sapiens come from Morocco, dating to about 300,000 years ago. But our species likely emerged gradually across different populations in Africa, mixing and moving over tens of thousands of years. Anatomically, we looked much like we do today. High-domed skulls, flat faces, prominent chins. Our brains were the same size as modern humans, around 1,300 cubic centimeters on average. But we weren't quite modern yet. Behavioral modernity, the full suite of symbolic thinking, language, art, and complex culture, may have emerged more gradually, perhaps fully flowering only in the past 100,000 years. Around 70,000 years ago, humans began leaving Africa in waves, spreading across the globe. We encountered our cousins, the Neanderthals and Denisovans, and as we now know from genetics, we sometimes interbred with them. If your ancestors came from outside Africa, you carry a small percentage of Neanderthal DNA. Some Asian and Oceanian populations also carry Denisovan genes. We spread across Asia into Australia at least 50,000 years ago. We reached Europe, where we coexisted with Neanderthals for thousands of years before they disappeared. We crossed into the Americas perhaps 15,000 years ago, or earlier. The evidence is still being debated. Everywhere we went, we left traces of our humanity. Cave paintings in France and Indonesia, jewelry made from shells, musical instruments carved from bone, elaborate burials that spoke of beliefs about death and what comes after. About 12,000 years ago, at the end of the last ice age, humans invented agriculture. We learned to plant crops and domesticate animals. Settlements became villages. Villages became cities. Writing appeared about 5,000 years ago. The wheel, bronze, then iron. Empires rose and fell, ships crossed oceans. Ideas spread, and here we are, you and I. connected across time and space by language and technology that would have seemed like magic to our ancestors. You are the latest chapter in a story that began 4.5 billion years ago. Every atom in your body was forged in ancient stars. Every cell in your body carries instructions refined over billions of years of evolution. You are the inheritor of an unbroken chain of life stretching back to those first microbes in the ancient ocean. Think about that. You are connected to everything, to the first single-celled organisms, to the fish that crawled onto land, to the mammals that survived the asteroid, to the first humans who looked up at the stars and wondered. And that's the story. 4.5 billion years from a ball of molten rock to you, listening to this right now. Pretty wild when you think about it. You're not separate from all of this. You're the latest episode in the longest running show in history. The same elements forged in dying stars are literally in your blood. The same water that filled those ancient oceans. Some of those molecules are in you right now. You are connected to everything. To the first cells, to the fish that crawled onto land, to the mammals that survived the asteroid, to the first humans who looked up at the stars and wondered what was out there. So let's talk about where we live. Earth is about 4.54 billion years old enough for continents to have wandered across the globe, for mountains to rise and crumble away, for life to evolve from simple cells all the way to you. It's the 5th largest planet in our solar system, and the only one not named after a Greek or Roman god. The name just comes from old Germanic words, meaning the ground, humble but fitting. Right now, you're hurtling through space at about 67,000 miles per hour, over 300 times faster than a race car. You don't feel it because everything around you is moving too. It takes us 365.25 days to orbit the sun, which is why we have leap years. Nature doesn't deal in neat, round numbers. Earth is tilted about 23 degrees on its axis, like a spinning top that's slightly off kilter. That tilt gives us seasons. And here's a fun one. When our planet was young, a day lasted only about 6 hours. The moon has been gently slowing us down ever since, tugging on our oceans. Days are still getting longer, just very, very slowly. We sit about 93 million miles from the sun. Light travels fast, but even so, the sunlight on your face left the sun over 8 minutes ago. And if you could walk around the equator without stopping, that's nearly 25,000 miles, about 2 years of continuous walking. Beneath us, Earth is layered like an onion, a thin crust we live on, a thick mantle below that, an outer core of liquid metal, and at the very center, a solid inner core. That inner core is as hot as the surface of the sun, around 10,800 degrees Fahrenheit, but stays solid because of the immense pressure squeezing it from all sides. The outer core is liquid iron and nickel, constantly churning. That molten movement creates Earth's magnetic field, the invisible shield protecting us from solar radiation. Without it, solar winds would have stripped away our atmosphere long ago. The magnetic poles aren't fixed either. They wander around and occasionally flip entirely. The last full reversal was about 780,000 years ago. Here's a wild thought. Earth's core contains enough gold to coat the entire planet in a layer about 1.5 feet thick. It's just unreachable, thousands of miles down. The deepest hole we've ever drilled, the Kola Super Deep borehole in Russia, goes about 7.6 miles down. Sounds impressive, but that's only 0.2% of the way to Earth's center. We've barely scratched the surface. Water covers about 71% of Earth's surface. From space, our planet looks unmistakably blue, a water world drifting through the darkness. Of all that water, 97% is salty ocean. Only 3% is fresh water, and most of that is locked in ice or deep underground. The Pacific Ocean is so vast, about 63 million square miles, that it covers more area than all the land on Earth combined. You could fit every continent in it and still have room left over. On average, the ocean is about 2.5 miles deep. Most of it exists in perpetual darkness, never touched by sunlight. The deepest point is the Challenger deep in the Mariana Trench, nearly 36,000 feet below the surface. If you dropped Mount Everest into it, the peak would still be more than a mile underwater. And get this, we've explored less than 5% of the ocean. In many ways, we know more about the surface of Mars than our own seafloor. Most of Earth's volcanoes, about 97%, are actually underwater, hidden along mid-ocean ridges where tectonic plates pull apart. The mid-ocean ridge is the longest mountain range on Earth. over 40,000 miles long, but almost no one has seen it because it's entirely beneath the waves. Every breath you take is about 78% nitrogen, 21% oxygen, and tiny amounts of other gases. Almost all of our atmosphere, 90% of it, is packed into the first 10 miles above the surface. Beyond that, it thins rapidly into the vacuum of space. The ozone layer, floating about 9 to 18 miles up, acts like sunscreen for the whole planet. Right now, about 6,000 lightning bolts are striking somewhere on Earth every single minute. That's nearly 9 million flashes a day. The driest place on Earth is Chile's Atacama Desert. Some weather stations there have never recorded rain. Parts of it haven't seen rainfall in over 400 years. Meanwhile, Moss and Ram, India gets an average of nearly 40 feet of rain per year. The hottest temperature ever reliably recorded was 134 degrees Fahrenheit in California's Death Valley. The coldest, a bone-chilling negative 128.6 degrees Fahrenheit at Antarctica's Vostok Station. At that temperature, steel becomes brittle and breath freezes instantly. And at any given moment, there's enough water vapor in the atmosphere to cover the entire Earth in about an inch of rain if it all fell at once. About 250 million years ago, all the continents were squished together into one supercontinent called Pangaea. Africa nestled against South America. Antarctica touched Australia. The world map looked completely different. And they're still drifting today, moving about as fast as your fingernails grow, roughly an inch or two per year. Mount Everest is the highest point above sea level at over 29,000 feet, and it's still growing by about a quarter inch each year as India keeps pushing into Asia. But here's a twist. If you measure from base to peak, Hawaii's Mauna Kea is actually taller. Most of it is just hidden underwater. Earth has about 1,500 potentially active volcanoes, and 50 to 70 erupt every year. The Ring of Fire around the Pacific contains 75% of the world's volcanoes and produces 90% of its earthquakes. About 500,000 earthquakes happen annually, though only about 100,000 are strong enough to feel. The ground beneath us is constantly, subtly shifting. The oldest rocks we've found are about 4 billion years old, discovered in Canada's Northwest Territories. They've witnessed nearly all of our planet's history. Scientists estimate there are roughly 8.7 million species on Earth, but we've only identified about 1.2 million. That means 86% of land species and 91% of ocean species haven't even been discovered yet. There's so much still waiting to be found. Over 99% of all species that have ever existed are now extinct. More than 5 billion species, gone forever. Life is resilient, but also fragile. The Amazon rainforest alone contains about 10% of all known species. Tropical rainforests cover only 6% of Earth's surface, yet they're home to more than half of all plant and animal species. Here's something wonderful. There are more trees on Earth than stars in the Milky Way. About 3 trillion trees, compared to perhaps 400 billion stars. The oldest living individual organism is a bristlecone pine in California named Methuselah, nearly 5,000 years old, older than the pyramids. But the largest organism might be a honey fungus in Oregon, whose underground network spans 2,400 acres. Invertebrates, animals without backbones, make up about 97% of all animal species. We vertebrates are the oddballs. Beetles alone account for over 400,000 known species. The biologist J.B.S. Haldane, when asked what nature revealed about the Creator, reportedly said, "An inordinate fondness for beetles. Every bird you see, from sparrows to penguins, is a living dinosaur, descended from feathered theropods. About 75% of our food crops depend on animal pollinators like bees, butterflies, and bats. A single gram of healthy soil can contain up to 10 billion microorganisms, more creatures than there are humans on the planet. More than 40% of our medicines come from natural sources. Penicillin, one of the most important antibiotics ever, comes from a humble soil fungus. A bit of mold changed the course of human history. Antarctica holds 70% of all fresh water on Earth, locked in ice sheets up to 3 miles thick. If it all melted, sea levels would rise by about 200 feet. Despite all that ice, Antarctica is technically a desert. It receives less than 8 inches of precipitation per year. It's just so cold that whatever falls never melts. The Sahara is the world's largest hot desert, but it wasn't always that way. Ancient cave paintings there show hippos and crocodiles. Permafrost covers about a quarter of the northern hemisphere's land, some of it frozen for hundreds of thousands of years. The Arctic is warming twice as fast as the rest of the planet, and changes there affect weather patterns worldwide. Emperor penguins can dive to 1,800 feet and hold their breath for 20 minutes. They're perfectly adapted to one of Earth's harshest environments. Our moon hangs about 239,000 miles away, the only world beyond Earth that humans have walked on. 12 people have left footprints there. The moon is slowly drifting away, about 1.5 inches each year. Its gravitational pull creates our ocean tides, the moon reaching down to touch us. Scientists believe the moon formed about 4.5 billion years ago, when a Mars-sized object slammed into early Earth. The debris coalesced into our faithful companion. We're part of the Milky Way galaxy, which contains somewhere between 100 and 400 billion stars. And that's just one of perhaps 2 trillion galaxies in the observable universe. In all our searching, Earth remains the only place where we've confirmed life exists. That makes our blue planet extraordinarily precious. The auroras near the poles, those shimmering curtains of light, are caused by charged particles from the sun colliding with our atmosphere. It's the sun painting on Earth's magnetic canvas. There are now about 8 billion of us. We've gone from a few thousand individuals on the African savanna to a species that has touched every corner of the globe. We've modified about 75% of Earth's ice-free land. Only about 23% remains true wilderness. Indigenous peoples, representing about 6% of the global population, manage over 20% of the planet's land and protect 80% of its remaining biodiversity. Traditional knowledge matters. Cities cover only 3% of land, yet more than half of all humans live in them. The first photograph of Earth from space was taken in 1946. The famous blue marble photo came in 1972, and it changed how we see ourselves. Earth Day started in 1970, and now over 190 countries participate. Our sun will continue to support life here for about another 5 billion years. We have time to learn, to grow, to take better care of this remarkable planet we call home.